Today we will be seeing the problem jump game. So in this problem, basically we are given an array and we will be starting at the 0th position, and basically we have to say whether we could reach the end or not. So there are certain more conditions. Suppose we are at the 0th position and the maximum number of jumps that we could make from this position is 2, because the element present at this position is 2. Suppose if we would have been at 3, that means we could make maximum number of jumps, that will be 3. So either 1, either 2, or either 3. Now let's try to think of the most brute force way to solve this problem. Suppose if we are starting at position 2, that means we will be having two decisions. Either we could go to the first index, that means the length of the jump will be 1, or either we could go to the second index. If we use the maximum jump, that will be 2. 0th or first. And from here also, if we are using only one jump, we will be reaching 3 or 1, and we could continue. Here we will be having 3 decisions. Here we will be having only 1. So as we can see, a tree is being made, a decision tree, which will be having many n number of decisions. That basically depends upon the number of the node that is currently present. So by looking at this, now we know that we will have to use recursion to solve this. But that will be very expensive, because suppose the number is 100. That means we have to make 100 decisions. And is it really a logical decision? No. So let's try to think about the optimized way. As we can see that we could reach one either via 2 or 3. So basically we are doing the work repeatedly. That means this is the overlapping problem. And in this case, we could use dynamic programming. So now let's talk about the dynamic approach to solve this problem. What we will be doing is we will be maintaining a data structure named DP. And this DP will contain the information about whether we could reach the particular index or not. So let's start with 0. Now let's see, can we reach this index? Yes, we could always reach this index. So we will mark the first position as true. Okay, now let's move on. Now we will check for the 3. Okay, now let's check. How many elements are behind 3? There is only one element, that is 2. So we will check whether we could reach 3 from 2 or not. How will we do that? What is the index of 2? That is 0. And what is the value? That is 2. And we will always be taking the current value. Means we will not be deciding whether we are jumping one steps. We will always be using the maximum number of jumps. So in this case, that is 2. Is this greater than or equal to this index of 3? Yes. Index of 3 is 1. So we could reach 3 from 2. So we will also mark this as true. Okay, let's move ahead. Can we reach 1? Now, how can we decide? We will see whether we could reach 1 from either from 2 or 3. Okay. Can we reach 1 from 2? Okay, 0 plus 2 is 2 and the index of 1 is also 2. So therefore we could reach 1. So we will mark this as 2 and we don't have to check for 3. Okay, now let's move ahead. Now let's calculate for this one. Can we reach from 2? No, because 0 plus 2 is less than the index of this one, that is 3. So we cannot reach from here. Now what we will do is we will be checking for the next element, that is 3. Can we reach 1 from 3? 1 plus 3 is obviously greater than 3. So we could reach this index also. So we will mark this as true. Now let's move ahead and check for this 4. Can we reach from 2? No. Can we reach from 3? Let's see. 1 plus 3 is 4 and the index of 4 is also 4. Therefore, we could reach the 4 also. That means if the last position in our DP is true, that means we could reach the end. But there is still one more edge case remaining. Let's see that. Suppose we have an array like this: 1, 0, 1, and 4. So now let's see. Now let's make another DP, let's say as DP2. We will always be reaching the first index, that we know. So we will be always marking the 0th position as true. So can we reach the first position? Let's see. 1 plus 0 is equal to 1. So we know that we could reach this index. Okay, we will mark this as true. Now let's move ahead. Now can we reach this position? Okay, let's check. First we will calculate here. Is 1 plus 0 greater than, what is the index of this? 2. No, this is actually less than 2. So we couldn't reach this index via this one. So we will not do anything. Now we will check from 0. But we cannot jump from 0 anywhere. So that means this index is unreachable. So we will mark this as false. Now let's move ahead. 4. Can we reach from 4 from 1? No. From here? No. But we could reach 4 from here. And this will be an absolute blunder to mark this as true, because this position is unreachable. We will only mark 4 as true if the position from which we are calculating is true. But this is already false. So we will not calculate for this one. We will either skip. If we skip this position, we will directly reach 4 and we just breaks out of our loop. So basically what we will do is we will mark 4 as false. So in this case, this will return false as our answer. So now let's quickly code this up. This is the function that is given to us. Okay, now let's first write the base cases. What will be the base case? If the length of the array is 1. That means we are already at the last position. So we will always be returning true no matter what element is present. Okay, this is done. Now, what is the next condition that we should check? If the length of the array is greater than 1 and the first element is 0, that means we cannot jump. So what we will be doing is we will just return false if the first element is 0. Okay, that is also done. Now, what is the next step? We have to make the DP. Okay, let's quickly make that. New boolean, and what will be the length of this? The length of the array that is given to us. Okay. Now what we will be doing is, let's first mark all the indexes as false. And we will be using this function and we will mark everything as false. Okay. Now what we will do? We know that we could always reach the 0th position no matter what the element is present. So we will do that. DP of 0 as true. Okay. Now what we will do is we have to check for the rest of the elements. So we have to iterate. Okay. So where should we start? We should start at the next element, that is the first index. And we have to, okay, let's first start. We will be starting at the first position. And till what we will go? We will go till the end. Okay, we went till the end. Now how we should check? We should check for the previous elements. Okay, now how will we be checking for the previous elements? By starting at the 0th position and we should iterate till the current one. How will we do that? Let's see. We will be starting at j is equal to 0 and till what extent we should go? We should go till I minus 1. Therefore, our j should be always less than I. Okay, this is understood and we will be incrementing the j. Now, let's see. Let's check whether the ith position is reachable or not. Now, there is really one important base case. If the position we are currently at should be reachable. And how will we know that the current position is reachable or not? That's why we have to use the dp. If dp of j is reachable, then only we will check for the next condition. What is the next condition? J plus nums of j should always be greater than or equal to 1. If this condition is met, then we know we could reach the ith index. So we will be marking the ith index as true. If we mark this as true, then we know that we don't have to check for the rest of the elements. We know that we will be reaching this index somehow. So we will just break. And believe it or not, this is the entire solution. Now we just have to return the last element in our DP, and we will do that. And this signifies whether we could reach the end or not. Let's just submit that real quick and see. And yes, the code is running properly. And this is not a very efficient solution, but it is really important to see how the dynamic programming works. And this will really build up the fundamentals. I have also talked about the greedy approach in my previous video. Please check that out if you want a more optimized solution. And if you find this video helpful, please give it a like. It really helps the channel a lot. Thank you.